performance measures for binary classification. So assessing the performance of a classifier is what we need to indicate when we evaluate the regressor that is going to be the classifier, right? So nevertheless, there's a numerous different ways to look at the performance of a specific classifier. And so we need to look at some of these performance systems. So first, let's take a look at confusion matrices. So a brief explanation. First, we have to look at a brief explanation of type 1 error. So the type 1 error, which is false positives. Right, so it's incorrectly rejecting a true null hypothesis, right? So you have something that is not positive and you have deemed it to be positive. And you can also have a type 2 error. And then you might have a false negative. And that's incorrectly failing to reject a false or null hypothesis, right? So something that is not negative and that you have classified as a negative. So these four cases in statistical testing can be combined into a single matrix, and then that gives us a visualization to understand what we are looking at. And I guess the two cases we didn't mention are a true negative and a true positive, right? So if we take a look at a confusion matrix, it will look like this. And first, we're going to have a predicted value, and we're going to have an actual value. On our predicted value, sorry, let's start with the actual value. I'm building a 5s detector, right? So all of these are 5s. 1, 2, 3, 4, 5. Those are all classified as 5s. And these are all classified as not 5s. 7, 3, 2, 7, 3. These two here, I could give you that they're classified as a 5, but for sake of argument, let's say that they're not labeled as a 5, right? Someone wrote a very bad 3 and something else is cut off, right? Maybe it's the top of a letter or something. So we predict that all of these are not 5. So I predicted that the 7 is not a 5. So that's a true negative because it is not a 5 and it's predicted is not a 5. I predicted this 3 is not a 5, true negative. This 2 and this, what I assume is a 7, right? Predicted is not a 5 and it is a 5. I also predicted that these two are not 5s, which is a bit disheartening because they actually look like 5s, but no classifier is perfect, right? So this is a false negative because it has been predicted as not a 5, but it is in fact a 5. And then I've got positives. So I have predicted these 3 as 5s, the 3 and the 2 things that look closer to a 5. I will give you that they look close to a 5. They are going to be false positives, right? And then I've got my true positives, all of these that are 5s and are predicted as 5s. And then I have 2 other metrics here that we'll talk about later, but we can introduce them here. And they are the concepts of precision and recall, right? So precision looks at the comparison of your true positives and your false positives, and recall looks at the characterization of your true positives and your false negatives. There's also a term called accuracy that you're probably pretty well versed with, at least in a general sense, right? Someone comes in and they want to sell you a product and they say, I have 95% accuracy. You say, okay, what's your recall? What's your precision? These are some of the terms that, a class like this is hoping to get you to explore. So when someone comes to sell you a product, at least you know some good questions to ask back. So this is a confusion matrix. It's not supposed to be too confusing. This is a 2 series confusion matrix, a binary confusion matrix for 5 or not 5. But we can expand this out to more things. And we are not going to do multi-class classification yet. But I think it's helpful to look at a confusion matrix for multi-class classification, and then we can start to talk through it. So these are my actual digits of 0 to 9 in the MINTS data set. This is not the entire data set. This is just part of it. I think the first 1,000 data points, and I built it this way just so the numbers were more manageable to talk through, and then the estimated digit. And what you'll see here is that, depending on what you classify, right? Nines are often misclassified as fours. And let's see, if fours, yep, are pretty often misclassified as nines. So, a 4 and a 9, if you think about it, a 4 and a 9, I mean, that 9 could be a 4, right? So that makes sense. Zeros are pretty much always classified as zeros. Fives get classified as 8s quite a bit. A 5 and an 8, yeah, I could see that, right? Particularly if my 8 looks more like that. So, and remember, this isn't an intelligent system looking at this. All this is a number of features, 784 features, and trying to find the features that help you guess if this is a 5 or an 8. So this is what a confusion matrix looks like for multi-classes. And we can break this confusion matrix down yet again. So, I don't know if it'll, oh, okay, so it will. Let me just move all that to the side. And then pull in this lovely image. So let's take one single piece from this multi-class confusion matrix. I'm going to try to do this in red. So let's take 5s. Everything that is a 5 and is predicted as a 5 is going to be a true positive. Makes sense, right? Predicted as a 5, not a 5. Everything that is predicted as a 5 but is not a 5 is going to be a false positive and a false positive. That makes sense. And then everything that is actually a 5 but is not a 5 is going to be a false negative and a false negative. Also makes sense, right? And then everything, let's go with orange, everything out here and here and here and here, these are all going to be true negatives, true negatives, true negatives, true negatives. So our goal is to understand the difference between, true negatives and false positives, false negatives and true positives. And then we can start from that, we can start to build up metrics for classification and ways to justify or quantify the quality of the classifier that we've built.